Hello, and welcome to Math Lessons with Linda. Today's topic is Descartes' rule of signs. We are going to use this to help us determine how many different roots, positive or negative, we can have for a polynomial function. So our first function is f of x equals 4x to the third minus 9x squared plus 6x minus 1. If we want to know how many possible positive roots this polynomial has, we're going to start with the beginning term, and if there is a sign change between the first and the next term, that's one potential positive root. So I have one sign change here, so that is one possible root. From the second term to the third term, there's another sign change. So that's two possible positive roots. And from the third to the fourth, I have a third. So I have three possible positive roots, but the law of signs says that I can decrease this number by 2. That would be another option. So I have 3 or 1 possible number of positive roots for my polynomial. If we look at what our exponent is, 3 is the maximum number of roots for this function. So it could be that I have all 3 that are positive. Let's see. We're going to figure out now how many possible negative roots we have. And in order to do that, we do f of negative x. And the first thing we're going to do is substitute in a negative x everywhere I have an x. This will change the signs on the terms that have odd numbered exponents. So this will be a negative 4x to the third. The 9x squared stays negative. The 6x term is now a negative, and the constant stays negative 1. So these are going to be possible negative roots for this function. Again, I look for how many sign changes I have. All 4 of my terms are now negative. So what that tells me is I have no possible negative roots for this function. So what that tells me is that I either have 3 real positive roots, and that's all of them, or I have 1 possible positive root, which would mean the other 2 roots for my function are imaginary. And that is how I use Descartes' rule of signs to determine how many possible positive and negative roots I have in a function.